Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za. The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
28 minutes to 10 o'clock, and yes, it's time for the Naked Scientist, Chris Smith. We're taking your calls, your SMSs, your tweets, so have a ball. Choose whatever platform you want. 021-446-0567, 011-883-0702. We're taking your SMSs on 31702 and 31567. Chris, good morning. Lovely to be with you again.
Hey, good morning.
Thank you so much. I just saw a headline about global warming, that it's cooling down. Surface temperatures around the world have not increased on average since the late 1990s. And I'm just wondering, without even getting into specifics about this story, is there still this raging debate about climate change? I thought most of the world was on the same page about it. But what's happening in the scientific community?
Yeah, I did too. You're quite right. But I don't know, because I'm not a climate scientist, and it's a really hard problem to solve, because you're talking about the entire planet, and you're talking about the fact that it's not just one system which has got some heat coming into it and everything warms up at the same rate. You've got a complicated system with bodies of water moving around, ocean currents, air currents delivering heat and energy to different parts of the planet's surface. And so you've got to be really careful when you make these sorts of measurements, that you're comparing apples with apples and oranges with oranges. You can't just say this bit's warmed up and that bit's cooled down, one cancels the other out, things aren't really changing. It's very difficult to therefore understand exactly how the Earth works. And what scientists are trying to do is to make what we would call a model. In other words, you reduce everything to a very simple representation of how we think it works, and then you ask, if that changes by this amount, what's the impact in the future? What does the model predict? And that's what scientists are doing. But the problem is the models are really, really complicated, even in simple forms to make. And there are always going to be errors, there's always going to be variability, there are always going to be things you hadn't thought of. So as we learn more about how the Earth works, we enrich our models and make them better. And that's why weather forecasting is getting better all the time. Not perfect, but it's getting better. And it's exactly the same here with longer-term predictions. So I think the one thing you cannot argue with here is that if we take the whole planet and we change the level in the atmosphere of a gas, carbon dioxide, by more than 30% in just a couple of hundred years, there is no way that this will not have at least some kind of consequence for the Earth. Now, carbon dioxide is a greenhouse gas. It does increase global temperatures. We know that. But that aside, it also is an acid. So when it dissolves in the ocean, it makes the oceans and other water become more acidic. And this is happening right now. We can measure the fact that 100 years ago the oceans were a lot less acidic than they are now. And that must have a consequence. Whether it will have a huge consequence or a small consequence, at this stage we don't know, but it certainly could affect the way that certain organisms grow shells or go about their daily business.
All right, thank you very much, Chris. Let's go straight to the lines then on 021-446-0567, 011-883-0702. Is it Pietro in Pretoria? Hi.
Hi, I've got a question about using olive leaf extract to treat parasites. Apparently, olive leaf extract, when you it combines with calcium in your body, and that creates something which I can't remember the name of, that kills basically anything that shouldn't be in your body, including parasites. And that just sounds a bit extreme to me. I would have used it to cure cancer if that was the case. But my question is really, would it cure a parasite like Bilharzia, which is a more tough parasite, not your common everyday variety?
Petra, what was the name of the substance? Because I couldn't catch that.
Olive leaf extract.
Olive leaf extract.
Yes. Yes.
Chris, I don't know anything about it.
I, to be honest, I really don't know the answer to this one. I don't know what that stuff is, unless it's just taking the extract of olive trees.
It is. That's what it is. Apparently, it originates from the Mediterranean, where it was used to brew a tea. Olive leaves were used to brew a tea, and it's apparently quite a bitter substance, and you can drink it in a medicinal format now. You can buy it.
Well, that sounds interesting, Pietra. When one hears about natural remedies and things, one shouldn't disparage them for the simple reason that probably the top 3 or 4 drugs used internationally in hospitals have their direct origins in nature or are made from plants. And you could take aspirin as a good example. Although aspirin is made as a chemical, the base chemistry was informed by a material called salicin, which came from the bark of willow trees, very good anti-inflammatory. Digitalis-type drugs, which come from foxgloves. There are new drugs for cancer, like the taxanes, that come from yew trees. So chemicals from nature are big business, and they're very exciting, because there are inevitably chemicals in plants that we can use medicinally. People who smoke are using another plant alkaloid, nicotine, and people who, like me, have got a cup of coffee in front of them this morning. They're drinking caffeine, which is another plant alkaloid, and plants make these things actually to kill bugs. They make nicotine and they make caffeine as natural insecticides to stop bugs eating them. And so, not surprisingly, these chemicals which work on living insects because they target their nervous systems, they also work in us. So I wouldn't be surprised if there were not chemicals in some of these things that you've been mentioning that might impact on parasites and impact on them in the way that caffeine or nicotine does on some insects. They might target certain aspects of their life cycle, but I don't know the answer to this particular one. I can certainly have a probe around for you and see what I can flush out. But it's an interesting area anyway, and certainly big business, especially in Africa. Pharmaceutical companies are very interested in talking to people in rural bits of Africa where folklore means that they often understand that certain combinations of plants or berries or roots will deal with certain conditions. People have discovered that for themselves, but the chemistry that's going on there could be scaled up and used to treat bigger populations of people if we can work out how it works. So it's certainly big business.
Thanks, Pietro. Let's go to Tori in Pretoria. Hi.
Hi, good morning. I'd just like to ask Chris, is there a tablet available that changes the melatonin in your system that you can have a permanent suntan?
Oh. Now that would be nice, wouldn't it? It's difficult. The reason we have a suntan is because your melanocytes, which are the cells in your skin which produce the dark pigment melanin, are responding to a signal called MSH, melanocyte stimulating hormone. So if you want to have them chronically active, then you've got to supplement that hormone, or you've got to increase the thing that it's made from, a big protein in the brain called pro-opiomelanocortin. Now, there are some diseases that can make you have skin pigmentation for various reasons, and these include a condition called hemochromatosis, where people have a bit too much iron in their body, and certain cancers also trigger the production of a chemical a bit like this MSH chemical. So it's not impossible to make yourself go darker chronically, but usually the people who look like this are not healthy. So we don't think that there's a simple way to activate these melanocytes and do it chronically in a safe way, unfortunately. So you may have to resort to something that like some spray-on tan or just a modest dose of sunshine.
Thank you very much, Tori. And then, Chris, I'm cheating. I've been going through your Twitter account and some of the issues that are raised on your BBC program and what you get asked. And one of them is standing under a tree during a thunderstorm, and we well known for the thunderstorms here on the Highveld. So why is it not a good idea to stand under a tree during a thunderstorm?
Well, when we have big thunderstorms, what is happening is that there is a distribution of charge in the part of the sky in the clouds directly above a certain geography. And this concentration of negative charge creates a strong electric field between the bottom of the cloud and the ground. And eventually the air, which is normally a very good insulator, can ionize. That means you get charged particles, and charged particles can carry a current, and so the charge dissipates from the base of the cloud down towards the ground. Now, if the ground is featureless and flat, then it is harder for the electricity coming from the cloud to pick a point where it's going to discharge down to. But if you have tall objects, these have the effect of distorting the electric field and focusing the electric field a little bit around the top of those tall, sharp objects. And this is how a lightning conductor works, partly, on a big building. So your tree is effectively distorting the electric field and encouraging the discharge to come down towards it. If you're on the ground near the tree, then several things can happen. One is that the tree may well explode because the current that's flowing through the tree is going to be thousands of amps, and the tree is literally going to be at thousands of degrees. And if the tree is full of sap, then intense heating of the tree can cause the sap to boil inside the wood. And in the same way as when you put a damp log on the fire, it can spit and crackle. Sometimes these trees literally explode and they go bang. So that may obviously cause serious injury. But more importantly, when the electricity is coming down the tree, a human standing next to it is also distorting the electric field, and a human is a big bag of salty water full of charged particles that would love to conduct electricity probably better than the tree. And you can sometimes get this phenomenon called a side flash, where current flowing down through the tree will also jump sideways into an object nearby, which is an equivalently good or even better conductor. And there have been cases of people who have, there was a man who was running, I think, in New York a few years ago, and he ran past some trees, and lightning hit one of the trees. The lightning came down the tree, jumped sideways onto the man, and then it threw him, I think, 7 or 8 feet across a road. Oof. And he turned up in hospital with very strange injuries because he had these lines running up his chest, up his neck, and then into his ears. His eardrums were ruptured and he had blood coming out of his ears. And it turned out that he had been running along listening to his iPod, and the metal wires were better conductors even than he was, so the lightning had gone up the headphones into his ears, and because the earphones were sealing off his ears, the earphones had exploded into his ears, making the air inside his ear canal very hot. It expanded and busted his eardrums, and also the lightning passing through his body activated all his muscles and threw him 7 or 8 feet across the road, breaking both of his legs in the process. Now, we speculated he was probably listening to Delicate Sound of Thunder by Pink Floyd on his iPod at the time, but we just speculated that.
Let's go to, we're taking a break first. Sitsiye, Mashuk and Mpho, stay on the line. I'm going to chat to you when we return.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
14 minutes to 10 o'clock. Our lines are open for you. 021-446-0567 or 11-883-0702. Let's go to Mpho in Johannesburg. Hi there, Mpho.
Morning, Rudy. How are you?
Fine, thank you.
I'm fine. Just a quick one for me. Just want to know, why is it not safe to transport the gas cylinder in a lying position, but it must always be transported in an upright position, even if it's a short distance? Thank you.
Hello, Mpho. I'm going to have a bit of a guess on this one, but I'm sure my friends at Afrox can help me out if I get this wrong. Now, for some, in some situations, if it's just gas in the cylinder, it probably doesn't make any difference whether it's lying down or standing up, because gas is gas. But some types of chemicals, when they're placed in cylinders, are not transported just as a gas under pressure that can sometimes liquefy. Sometimes, and I'm thinking specifically like the gas acetylene, the gas is soaked into or dissolved into or adsorbed into another substance inside the cylinder, like acetone or something. And when you depressurize the gas, so in other words, you open the tap on the cylinder, then the gas comes away from the things that it's adsorbed into. And so if you let the cylinder lie over, then that would come out rather than the gas. I think that's the reason, but if I've got that wrong, Afrox or BOC, Lindy, whoever make these bottled gases, please tell me. You can tweet at Naked Scientists and I'll put it right during the programme, but I think that's right.
All right, and we have a lot of gas experts and suppliers here. I'm sure they'll also call us to give their perspective. Let's move along. Sitsiye in Pretoria, hi.
Hi, Reddy. And hi, Chris.
Yeah.
I just have a short question. I just like to know, all the electronic devices, they've got the small components on the motherboard, and those components consist of chemical-like substance. So I just need to know how does that chemical be able to transform and store information, whether it's pictures, voices, and all of those things. Thank you. I'll listen over the radio.
Thank you very much. Chris?
Yeah?
Really, could you just summarise the question for me, because it wasn't a terribly good line?
Okay, what he was asking was, how is it possible for electronic devices to be able to capture and retain some of the information, including images?
Well, when we use digital storage, what we're effectively doing is taking information and turning it into a pattern of noughts and ones, which is in a sort of code that the thing that writes that code and the thing that reads the code understands. So let me put this in a different way. Let's take music as an example. So if I'm singing or I'm listening to someone singing and I record it with a microphone, the sound waves coming from the person singing are a wiggly series of waves coming through the air, and they go into my microphone and they make the diaphragm in my microphone vibrate at the same rate as the sound waves coming from the person. This makes a pattern of electrical signals in the lead from the microphone, which are going to reflect that pattern of sound waves. So you get it going up and down, up and down, up and down, and the voltage is therefore going up and down, up and down, up and down. When it goes into the recorder, in the old days with cassette tapes, magnetic tape, what it did was to record a signal in an analog format that was identical to that voltage going up and down on the tape. But with digital, what it does is there is a sampler. In other words, there is somebody, it's like the equivalent of a miniature person, and every fraction of a second, they're writing down how big the wave is. So is it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Let's pretend these are just pretend numbers. But they'll write down a little number, which is the size of that wave. And then a fraction of a second later, they'll do it again and again. So they'll get a series of measurements plotted on in a list, which means that if they were to draw all those numbers as dots on a piece of paper, they could recreate the wave. Now, you can't possibly store all that information. So what it does is it then puts that into a code of noughts and ones, which it understands. And so it says, right, instead of writing down 25.6, 25.7, 30.2, I will write down a code which means those numbers as noughts and ones. And those noughts and ones are then written into the memory on your storage card or your compact flash or smart media as a series of noughts and ones. They're then read back off of that when you want to play the music back, or with the CD, then you've got little pits on the surface of the disc which are read back, and they will again generate a series of noughts and ones, and the same code that was used to generate those noughts and ones is used in reverse, and it knows that a series of noughts and ones that's written in the following way, that translates into the number 26.5 on that wave, or 26.6, and it rebuilds the waves back into analog again when you decode the signal. And so the benefit of digital is that it's lossless, in the sense that when you recreate the signal from the digital impression, then you've got a nice rendition of the wave. You can have what's called compression, though, which is where you throw away some of the information in order that you don't have to store so much data, but you throw away the bits you can't hear largely.
Thank you very much. And Chris, I said earlier that hopefully someone who knows a lot about gas and its storage will phone us and educate us. And I specifically said we have a lot of gas experts. Now, this guy, Mags Naidu, has posted a tweet saying, that's really no way to speak of our politicians, Reedy. So the politicians are gas experts. That's not what I meant, Max. We're talking about real experts in this regard. Let's go to Attila in Durbanville. Hi.
Hi there. Morning, Chris. Chris, if one presumes that a higher body temperature makes your immune system work more efficiently, then why should we bring a fever down with paracetamol, for instance? Are we doing ourselves a favor?
Yeah, good question. So when we have an infection or something, we generally have a high temperature. Why do we get a high temperature? Well, people think the reason that we run a fever, and it's not definitely known, but we think the reason we run a high temperature is because the idea is that we can tolerate the high temperature better than the bug that is infecting us, and this will make the body a less optimal place for the bug to grow, and it will give us more of an advantage. That's sort of the theory. Whether it's true or not, I don't know. But the reality is, if you bring the temperature down with a drug, then you do feel better, because when you have a fever, obviously you feel very unwell. But does this in any way harbour or hamper our recovery time? I don't think there's any clear evidence that it does, in the majority of cases, slow down healing time. So any benefit of running this intense fever probably is marginal in terms of our ability to fight things off. Personally, I think the reason we get very hot when we have an infection is because if you look at what your body is trying to do to fight off that infection, it's mobilising enormous numbers of immune soldiers. You're making millions of new white blood cells. You're making millions of antibody molecules. And this requires a huge metabolic effort on the part of the body. And to generate that metabolic effort, it has to up your metabolic rate. And if you up your metabolic rate, you will generate heat. And I think, therefore, it's merely a consequence of the fact that you're metabolically more active when you've got this going on. If you take the temperature down a bit, you might be reducing the rate at which some of these processes occur slightly. But if bringing it down makes you feel a bit better, and then you go and get a drink and eat some food, and that gives you more energy, actually, it's no net worse off, is it? Because you're now in a better condition to fight off whatever you are battling against. But it's a dark art. We really don't know the answer to that question.
Chris, I've got an SMS here. Somebody wants to know, why do people behave strangely when it's full moon? Is there a relationship between how we behave and the position of the moon?
Yes, that person presumably has read this paper in Current Biology this week, which I was reading. I actually happen to have the paper in front of me. Christian Cahocan and his colleagues from, he's at the University of Basel in Switzerland. And this group have found that people sleep less well when there is a full moon compared with when there is not a full moon. And they actually did the study by using individuals who went to do a sleep study in a laboratory about 10 years ago. There were 33 men and women, they say. And they happened to have all the data from these people who'd gone into the lab to be studied for something else. And so they compared the data they got from these people with what the moon was doing. And they were really quite surprised to see that the people who were doing the study at the time of the full moon had a 30% reduction in the pattern of brain activity that indicates deep sleep. They took 5 minutes longer on average to go to sleep, and they took 20 minutes less overall sleep that night when it was a full moon compared with nights when there was not a full moon. And they don't really know why this happens. They suggest that there must be some kind of what they dub a circa-lunar clock running in our brains, and therefore, in other words, we're somehow tuned into the 29.5-day cycle of the moon. Why we should have this, they don't know. How it works, they don't know. But they do point out fairly tantalisingly that there are some animals that are very dependent on the moon cycle, including, for instance, a certain species of Galapagos marine iguana that feed at certain times of the tide, and therefore being aware of when there are going to be higher or lower tides would enable these animals to optimise their feeding and therefore beat off the competition. So it might be that in the past, knowing what the moon was doing was very useful to us keeping track of time seasonally as humans, and we still have a legacy of that today, which is why we're sensitive to it.
Alex, I'm sorry that we can't take your question, but I promise you next week you will be our first caller. We'll take your details and then we'll phone you next week. We've run out of time again, and Naked Scientist, as always, lovely to have you with us.
Where did the time go?
I know. I can't get used to this. I mean, it's 9:30 and then I blink, it's 9:57 and I have to say goodbye to you. Cheers, Chris.
Take care, Reedy. Bye, everybody.